All right, so this is the back end of my windmill. This is a 98mm motor mount. This was originally designed to be a sustainer on a two-stage rocket, so the back end of this is open to receive a coupler if needed. Now this is a 98, but we're going to use a 75. So the first thing we're going to do is put in our thrust plate. You'll see here, I guess there are some holes here where you could bolt this through a bulkhead. So if you have a rear bulkhead, you could put some T-nuts, or if you're using a wood rear bulkhead, which you can mix with fiberglass, before you bolt all those things on, you can just screw this directly into the bulkhead on the back. Okay, you're not going to do radial here, you're just going to do some retention bolts. Okay, so this comes all together, and then this slides onto this assembly, and now this aluminum, when the thrust comes on to this metal, is transferred directly to the outer body tube, and it reduces your stresses on all your joints. Okay, now this is a 75mm motor, so we're using an adapter ring here. This slides down, and then on the front end of this, you'll see we have the forward closure, and this is into an all thread. This one has a countersunk screw radially on it to help make sure this all thread doesn't come twisted out, but there's some other ways to do that. And this is just a centering ring. Okay, so this is going to come in, you're going to lock here, there's this rear retention plate there, that's just for the adapter, and then this comes on. Okay, so now this won't go forward, but you'll see I can pop this whole thing out with the thrust plate, which is our problem. Okay, now again, if you use those retention holes in your thrust plate into a bulkhead here, or a centering ring, you're going to be fine. Now if we flip this around now, we'll see that this all thread comes out the top, and this is open to this 98mm. Let's take a wood bulkhead here. We're going to put this over retention here. We'll get a washer that just helps distribute our forces, and then we're going to get a eye-nut, and we're going to put this on here. Okay, I'll twist this down. Now I'm using soft links here, but you can use quick links. I like soft links more. But you'll notice there's a swivel here, so any twisting force isn't going to be transferred over to your eye nut. On descent, when you're under parachute, these fins tend to catch air and this bottom section twists a lot. Okay, so this goes down. You'll see we have some extra thread here. I'm just going to take a locking nut. This is nylon. I'm not going to put this on all the way for now for the demonstration, but you'd put this on above, maybe a locking washer in there, and then make sure none of this comes undone. Now, again, this recovery, all this weight is being transferred through the motor case. It's not coming on this bulkhead. It's not putting stresses on our epoxy joints. It's going from here to the eye nut, to the all thread, to the motor, back to the thrust plate. So the same strength and things that you're getting the thrust plate for during ascent to hold, you know, over 1,000 newtons, is easily going to be able to transfer and carry that weight during descent through that recovery. But now you're not ripping out bulkheads here. And if we flip this back around and try to pull this out, this will not come out because that forward bulkhead is holding it. Again, there's not going to be a ton of force on here on the rear. It's only during the ejection event that there's really rearward forces on here. It's not going to put a lot. And then once it's under drogue or under parachute, all the forces are back in the other direction, pulling this direction, and the thrust plate's going to support that.